This episode of The Trainer is sponsored by Autel. Our problem child today is my personal F-350 Ford dually with the 6-liter diesel engine. The story of how I ended up with this behemoth is something I'm going to have to save for another time, but right now I need to figure out what caused the ABS warning lamp to come on. The first thing I have to do is figure out exactly what kind of a problem it is that I'm trying to repair. So my first stop is going to be connecting my scan tool in enhanced mode, that is with OEM specific software, so I can access the ABS ECU and find out what code or codes are stored there. Now, whenever you find yourself connecting to a vehicle in enhanced mode, make sure that you perform a full system scan. In other words, while you're hooked up, check every module on the vehicle to see what problems may be stored elsewhere. You never know when a problem in another system may lead you to the cause of the problem in the system that you're troubleshooting. In addition, if you do see systems problems because of that full system scan, it's a good thing to share with your customer so they can make an informed decision about how they want to proceed from there. The very first thing I notice is that the ABS module shows no response. And I know there's an ABS module on this vehicle. I can also see that there are 3 other modules reporting a fault: the powertrain control module, or PCM, the instrument cluster module, or IC, and the trailer brake control module, or TBC. Now, the code in the PCM is one that I accidentally caused, so I'm not going to worry about that one for now. However, the other 2 are reporting a U1900-60, a CAN communications bus fault. And that's rather fitting considering this is a video on how to diagnose a CAN communications problem. There are a few things that we need to know before we even begin our troubleshooting. For example, just what networks are there on this vehicle and what modules belong to which network. Another thing I want to know is, do the networks pin out at the DLC, allowing me a direct communication with my scan tool, or do I have to get that through a gateway module? I also want to know, are there any networks on the vehicle that I can't communicate with? Now that I know what the code is, it's time to do some homework. But before I get into that, there are some features of the MS919 and its cousin, the Ultra, that are very beneficial in trying to track down these type of problems. Now, unfortunately, I can't share it with you on the old Ford because it doesn't go quite that far back yet, but it is offered on a lot more later model vehicles with that library increasing all the time. So let me show you exactly what I'm talking about. So let me show you on this vehicle. It's a 2014 Scion TC, and we're going to do the same thing that I just did on the F-350. We're going to go ahead and connect and perform a full system scan. Now I have 2 options. I can look at the modules in a list format, or I can actually view the topology of the different networks on the vehicle and identify what modules belong to what networks. Now, if you've ever used a Chrysler factory tool, you'll recognize this format. Only now this feature is available for several OEs with more additions planned for the future. Another nice feature is the ability to quickly switch over to scope mode and check the CAN signal directly through the DLC connection. This quick check can help you identify potential problems with the network's termination resistors or the integrity of the bus wiring. Now, while you can only see one side of the signal at a time, either CAN high or CAN low, if there are any problems with the signal itself, you will be able to see it here. And then if you want to, you can go all out scope mode with the MS919 and take a better look. Now, the next step, of course, is to check for any applicable technical service bulletins that may apply to the problem that you're trying to diagnose. Once you've completed that, you next need to move to the DTC definition. You want to find out what the code setting criteria are and what the code really means. Now in this case, it's pretty straightforward. It means that the two modules in question are expecting to hear from a third and they're not getting the message. And that's a tip you want to keep in mind when you're dealing with these type of problems. If you see that there are codes set in numerous modules all pointing at a single module, then odds are pretty good that's where your problem lies, and you should begin your troubleshooting focus there. And while the code definition doesn't specify what that third module may be, I think we all have a pretty good idea of which one it is. But to be sure, let's pull up the communication bus network diagram to see exactly who's on what network. There are three networks on the Ford. The first network is a single wire ISO 9141 bus that, unlike CAN and other networks, does not support intermodule communications, and it connects to the DLC at pin number 7. The second is a UBP, or Universal Power Line bus. It too is a single wire network, but this one does allow for intermodule communication. It connects at the DLC at pin number 3. And finally, there's CAN. That stands for Controller Area Network, and many late model vehicles may have 3 different CAN networks on them, operating at different speeds, which means how fast they're able to transmit data from one module to another. Now in the case of the F350, there's only the one CAN network, and because it's tied to the powertrain, this data needs to be transferred right here, right now, and it uses CAN C, the fastest of the 3. Going back to the network diagram, you can see that there are only 4 ECUs on this single CAN network: the PCM, the ABS, the TBC, and the IC. And it connects to the DLC at pins 6 and 14. Now remember the system scan that we performed earlier? The ABS module showed no response. And since that's the only unaccounted for module on the CAN network, I think we're all pretty sure that that's the missing module. Now I want to point out here that since all 3 of this vehicle's networks pin out directly at the diagnostic link connector, there is no gateway module in the system. Now what is a gateway module? Well, it's a module that allows the different networks to share data. Think of it as a translator of sorts. So when you're looking at your communications network diagram, look for modules that have more than one network going to them. There can be more than one gateway module, but typically it's just a single module, usually a body control module of some type. Now you also need to know, does the factory security software allow you to directly access the network through the gateway, or do you have to depend on the gateway feeding you information indirectly? This could affect how you view the CAN signals on your lab scope. Now while the Autel tool allowed me to inspect the CAN signal, albeit one channel at a time, through the DLC, what if your tool doesn't offer a similar feature? Let's take a look at how you capture that pattern on a regular scope. Now you can back probe the diagnostic link connector at pins 6 and 14 using a common ground, but better yet, invest in a breakout box, also known as a bob, and use that connected to the DLC instead to avoid any potential damage to the connector. Now what settings do you think you would need for your time and voltage? Keep in mind that networks transfer data at very high speeds. So let's start with a very short time setting, say 100 microseconds per division. Now some networks may use an 8 or 12 volt signal, pulse width signal, to allow for communications among the modules, but a CAN network is biased at 2.5 volts, with the CAN H or high signal being pulled upward and the CAN low or L signal being pulled downward when communications occurs. So we'll only need to set our scope to about 1 volt per division to get a clear picture of the signal. And as for your trigger, don't use one. Allow the signal to stream. This way you'll be sure to see any glitches in the signal that you might otherwise miss. Now here's what a normal pattern looks like. There's a little bit of noise in the capture, but if you look, you can see the segments where the CAN H line is being pulled upward and the CAN L line is being pulled downward when communications are being sent along the bus to other modules. And when the bus is quiet, you can see the voltage stabilized right around 2.5 volts. Now each segment you see is a message that's being transferred from one module to another on the network. I don't really care though what module is sending or what module is receiving or even what the message might be. I'm more concerned about the quality of the signal. If I see any abnormalities in the pattern, I'll need to focus my troubleshooting there first. Since I'm dealing with the loss of communications with just one module, my troubleshooting focus is now going to center in on that module. I'd like to know, are there CAN signals present at the module? If not, there could be a break in the CAN network between the module and the point where it splices into the bus. I also need to be very sure that I check and verify that the module has good power and grounds. Any electrical component, no matter what it is, cannot function properly if it's not getting a clean source of power and a good path back to ground. And the only way to properly test for this is by checking voltage drop in the circuit. Testing with the connector unplugged and using a test light is not conclusive, and it could result in an expensive comeback if you replaced a module that wasn't defective simply because your testing method was. Checking the wiring diagram for the ABS circuit, I can identify 3 different power supplies coming in from the battery junction box. Fuse 1.22 is a 60 amp fuse that is hot at all times. Fuse 1.23 is also a 60 amp fuse that is hot at all times. And finally, there's fuse 1.11, a 10 amp fuse that is hot only when the key is in the run position. Next, I need to identify the grounds going to the ABS ECU. There are 2. At ABS connector pins 16 and 45, and both ground at the frame at point G105. Now I don't know how these circuits interact within the module, but I think if we apply a little common sense, we'll be able to figure out where we need to connect to perform these tests. I'm certainly going to want to monitor both ground connections, so I'm going to assign one channel to each and back probe there. Now I have 3 power feeds to choose from, but I want to remember that this is an ABS or anti-lock brake controller. Now the anti-lock brake control module is not only responsible for monitoring the speed sensor signals and sending data back and forth to the PCM and other modules on the vehicle, it's also responsible for operating the hydraulic control unit. I'm pretty sure that the 2 60 amp fuses are tied to the operation of the ABS's hydraulic control unit, so I'm not going to worry about them for now. But I am going to assign a channel to the fuse at F1.11, the 10 amp fuse that is only hot when the key is in the run position. And that's going to leave channel 4 to monitor the CAN signal at the module. If I see anything funky going on, it'll be easy enough to move over to the other signal wire and monitor both at the same time. Now note this pattern shows a nice clean CAN signal, but there's no power coming in on the fuse F1.11. And since no power is coming in, no current can flow, which explains why our ground measurements are flatlined at 0 volts. So what should we check next? Now the fuse is the most likely suspect for a completely open circuit, so let's start there. I could use a test light, but instead I'm going to use Autel's built-in multimeter and test for the presence of power on both sides of the fuse. And remember, for this fuse to have power present, the key must be in the run position. Well, just as suspected, the fuse is indeed blown, so I'm going to install a new one, and then we'll go back to scope mode and check the pattern one more time. Now that's more like it. Good power, good grounds, good communications. Time to clear the codes and repeat the full system scan. Our scan shows that the ABS module is back online and communicating, and the U1900s are gone from the other two modules. So the vehicle's fixed. Or is it? I'd still like to know what caused the fuse to fail, so I'm going to take a closer look to see if there's any signs of heat damage that could indicate the presence of a short circuit. If it's clean and it's just a break, it's possible that the fuse just failed from normal vibration. Well, that sounds like the topic for another video, doesn't it? Hey, if you want any more information on the Autel MS919 or anything that I share with you today, be sure to visit www.autel.com. And as always, thanks for watching.